In this video, we're going to review the measurement of temperature, and that's defined here as the average kinetic energy of the particles in a sample. And you may notice or know this as the hotness or the coldness of something. And this also, we'll see in chapter 5, will determine the direction of heat flow. So again, this will become important in a later chapter, but let's look at some different units, some different scales that are commonly used for measurement of temperature. In the scientific community, you'll most commonly see Celsius and Kelvin scales used. And we can see a comparison of those units to what you might be more familiar with, the Fahrenheit scale shown here. So the Celsius scale, we should note in the middle here, is based on the boiling point of water and the freezing point of water. So that's what we see down here, the properties of water. And specifically, we have 100 Celsius is defined as the boiling point of water and 0 as the freezing point. So this can be correlated to a scale in Kelvin, where we see that 273 Kelvin is equivalent to 0 Celsius. And this is also equivalent to our freezing point that we're more familiar with for water, 32 degrees Fahrenheit. So let's look at some other aspects of temperature and different scales that it's measured in. So we mentioned the Celsius scale being based on water and these properties here. The Kelvin, this is actually the SI unit of temperature, even though you may not be familiarized with it. This is based on the properties of gases. And when we get to chapter 10 later on this semester, we'll review all temperature measurements must be in Kelvin. And it's also based on the value for something called absolute zero, where there's no kinetic energy measurable at 0 Kelvin. So there's therefore no negative values when we measure temperature in Kelvin. So if we wanted to convert between units, we could convert to Kelvin by taking the temperature in Celsius and then adding the same number to whatever that value is, whatever that temperature in Celsius is, 273.15. So say we had 25 degrees Celsius or around room temperature. We added that 273.15, that standard conversion rate, we would end up with 298.15 Kelvin. The Fahrenheit scale, this is not used in scientific measurements, but we still can convert if we're given a temperature in Fahrenheit to Celsius, or vice versa. So we see here, if we plug in temperature in Celsius and multiply by 1.8, we can find our or solve for our temperature in Fahrenheit minus 32 degrees. So we can rearrange this equation accordingly to solve for either the temperature in Celsius or the temperature in Fahrenheit, depending on what we're looking for. So in sample exercise 3 here, we'll utilize this equation. And we can solve for, in part A, the temperature in Kelvin, and then in part B in Fahrenheit. So we have a weather forecaster that predicts the temperature will reach 31 degrees Celsius. We want to know in A again here that temperature in Kelvin. So we just simply take 31 degrees Celsius and we add that 273.15 conversion factor. And we would find, after we rounded, we would have 304 Kelvin. So we can do something similar when we convert here to Fahrenheit. We can take that original equation up top there, so 1.8 times 31 for degrees Celsius, and that will give us our temperature Fahrenheit minus 32. So whatever this product is over here, we're going to get around 55.8. We can add to that 32 degrees, and that will give us our temperature in Fahrenheit. So the value there, after we round to just two digits based on our original value given, we would find our temperature would be 88 Fahrenheit for part B. Down here, there's a mention of something called a derived unit. Whenever we have a unit that is a combination of two or more base units, we refer to this as a derived unit. So something like meters per second, say, could be a distance over time or give us a unit for speed. If we wanted to measure something speed, we can measure it in 2 units, base units rather, and get this derived units of meters per second. The most commonly used units, metric units for volume, are the liter and the milliliter. So we'll use these throughout the course, especially in some of the laboratory simulations. And we should know that a liter is a cube with 1 decimeter, abbreviated dm, long on each side. So we could think of a shape kind of like this, and each of the sides would be 1 decimeter. So a cubic decimeter is another way of thinking of that. And then a milliliter, that is a cube with 1 centimeter long sides. So when we refer to a cubic centimeter, that is equivalent to a 1 milliliter volume. And one other example of a derived unit is a unit that's commonly used for density, which was mentioned previously as a physical property of a substance. It's also an intensive property, so it does not matter how much you have. And it's a ratio of the substances, the sample's mass, to its volume. So commonly, units that are derived, we could see grams per milliliter, or for gases, we commonly use grams per liter. So we'll continue in the next video with sample exercise 4.